Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to learn the different types of diffraction, namely Fresnel diffraction and Fraunhofer diffraction, and also the differences between these two types of diffractions. So, what is a Fresnel type of diffraction? In a Fresnel type of diffraction, you have a source of light from a finite distance from an obstacle, and also the screen too is situated at a finite distance from the obstacle. Let us have a look at it. So here is the source, and here is the obstacle, and here is actually the screen. So the source gives out rays of light, and these rays, because of diffraction, bend at the fine obstacle over here and enter into the geometrical shadow region. All of these rays merge at a particular point on the screen, and you have the diffraction intensity at this point on the screen. Similarly, we can draw ray diagrams for each and every point, and we can extrapolate what will be the intensity of the light at each of these points placed on the screen. So, what is the important criteria of Fresnel diffraction? The source and the screen are placed at a finite distance. Now let us go to the second category of diffraction. And what is the second category of diffraction? It is the Fraunhofer diffraction. In Fraunhofer diffraction, we have parallel rays of light which are coming to an obstacle, and once they reach the obstacle, these parallel rays of light bend simultaneously, right? So what is the main difference between Fresnel and Fraunhofer diffraction? The source and the screen, the distance between them is infinite. This is one of the most important differences in a Fraunhofer. This is one of the most important differences between the Fraunhofer diffraction and between the Fresnel diffraction. But are these the only differences between a Fresnel diffraction and Fraunhofer diffraction? No. There are additional differences also between the Fresnel diffraction and Fraunhofer diffraction. Let us study each one of them, or rather let us mention each one of them one by one. So to start with, first, the distance between the source and the screen in a Fresnel diffraction is finite. In comparison, the distance between the source and the screen in a Fraunhofer diffraction is infinite. The second point of difference between Fresnel and Fraunhofer diffraction is, in the case of Fresnel diffraction, the incident wave front and the diffracted wave front, they will either be cylindrical or they will either be spherical. Once again, the incident wave front in case of Fresnel as well as the diffracted wave front will either be spherical or they will be cylindrical. Unlike this case, in the case of Fraunhofer, the incident wave front and the diffracted wave front, both of these are plane surfaces. So this is one of the most important differences, the second important difference between Fresnel diffraction and Fraunhofer diffraction. What is the third important difference between Fresnel diffraction and Fraunhofer diffraction? The phase of the waves in the plane of the slit or in the plane of the obstacle, the phases are different in the case of Fresnel diffraction. In comparison, the phases of the incident wave in the plane of the slit, that is in the plane of the obstacle, they are constant, or they are the same. This is one of the major point of difference between Fresnel and Fraunhofer diffraction. Now let us come to the third one. In the third difference, in the case of Fresnel diffraction, you do not use any lenses, but in the case of Fraunhofer, you can use lenses because we need to develop Fraunhofer diffraction in the laboratory, and for developing Fraunhofer diffraction in the laboratory, you need a biconvex lens near the source, and there is a biconvex lens after the slit, that is near the screen. Here is the diagram for the Fraunhofer diffraction with the biconvex lens assembly. So as you can see that we have a source that delivers cylindrical wavefronts as in the case of Fresnel diffraction, but due to the lens it will start developing plane wavefronts, and this plane wavefronts, as was the case in Fraunhofer diffraction, this plane wavefronts will become incident near the slit, which is the obstacle. They will bend in the geometrical shadow region, and just near the screen I am placing another lens so as to bring all these diffracted beams to a single point of focus on the screen. So this is how in Fraunhofer diffraction you utilize two lenses, a two-lens system. So these are the main point of difference between Fresnel diffraction and Fraunhofer diffraction. Sincere thanks students for watching this particular video. Stay tuned to our channel eKida and do subscribe to our channel eKida. Thanks a lot.